with m to g over k. Clear? m to
واضح كيف طلعت من المسافة هذه اللي لازم يضغطها الزنبرك.
m to g over k. Okay? Everybody understood? This is the final situation.
هذا عندنا الحالة الأخيرة اللي هي لما نضغط الزنبرك من الأعلى نأثر عليه بقوة وينضغط مسافة مقدارها x.
The sponge. The sponge. Oh. Sorry, it was on the other side.
إذا لما ينضغط الزنبرك نأثر عليه بقوة وينضغط مسافة مقدارها x 3 سماها أظنيها x3 راح يكون عندي
x3 is m to g over k.
g على.
So, in this moment, yes, doesn't matter. Doesn't matter. Only here I wanted to show that the tension in the spring should be equal with m to g exactly in the moment when the normal is 0. That I wanted to show only. Because the problem asks, what is the minimal force that all the body get out of the ground? So when a body get out of the ground, when it has no contact with ground, which is the force who describe the contact? The normal. If the normal is 0, that means I have no contact. Okay? Now, this is the initial situation. This is the final situation. So, I can write the equality of the energy in the both situation. Let's see. In the initial situation, I began with potential gravitational energy, mgh. M2 has not, because h is 0. But M1 has, is M1 g. And what is h? H is this distance, which is L0 minus M1gk minus f over k. Everybody see? L0 minus M1g over k minus f over k. This is mgh. Okay? Then I am asking this spring is in the normal length or is deformated? It's deformated. His option of length L0 is here. Here he is compressed. Then I have elastic potential energy kx square over 2. Yes? Let's see. Plus k over 2 x square. But what is the deformation? This is the deformation. I think the camera show. This is the deformation. Yes? This was not deformated length. This is actual length. That means this distance is the deformation. So the deformation is m1g over k plus f over k square over 2. This is the potential energy of deformation. Again, this is the gravitational, this system here have to have gravitational energy, which is mgh. This body has the h0, no potential. This one have the h from here to here. This is m1g over this h. But this h can be calculated from here to here is L0 minus m1g over k minus f over k. Okay? On the other side, the spring is not at his length L0. The spring is compressed. So I have potential energy kx square over 2, energy of deformation. That is k. X, what is the deformation? The not deformated level is here, the deformated level is here. That means this distance is the deformation. M1G over K plus F over K. Yes? Square over 2. Everybody understood? I should see if I have here kinetic energy. No. It's stationary system. He's not moving. Now I take the hand, and the spring and the body are going up. Let's see again the energy. Potential energy here 0, because height is 0. But M1 is at this height, from here to here. That his potential energy is M1 G. From here to here is L0 plus M2G over K. L0 plus M2G over K. Plus the spring is deformated. His normal length is from here to here. But now he is here. So this is the deformation. Yes, potential energy of deformation. K over 2. Deformation at square. That means M2G over K square. Okay? Everybody understood till now? Everybody? So, the problem is...
Dr. Sandu, can you just give me 1 minute to at least
Yes.
be ready? All right. اللي بيحاول يعملوا الآن إيش بدهم نشوف نطبق مبدأ حفظ الطاقة في لحظة انضغاط الزنبرك لما ضغطناه ولما رفعنا يدنا عليه انطلق إلى الأعلى فراح يمتد الزنبرك المسافة اللي هي مقدارها x2 هذه للأعلى. x2 اللي أوجدها قبل بشوي اللي كانت تساوي عندي m2g على k. الآن بدي أشوف الطاقة، يعني مبدأ حفظ الطاقة بما أنه في عندي طاقة مفتقدة، كم مقدار الطاقة الابتدائية اللي بدأنا فيها لما ضغطنا الزنبرك، وكم مقدار الطاقة النهائية اللي في اللحظة اللي بدأ الجسم M2 ينطلق عن سطح الأرض. فأوجد المعادلات اللي عندكم. يعني في البداية كان عندي طاقة وضع زائد طاقة الانضغاط أو الطاقة المختزنة في الزنبرك، ونفس الشيء في النهائية أيضا في عندنا طاقة وضع لكن الجسم ارتفع مسافة مقدارها x3 زائد الطاقة المختزنة في الزنبرك لأنه صار عندي استطالة في الزنبرك في هذه الحالة.
Thank you. What? No. Till this moment I write on what I want is to find the minimal force I have to push the spring that all the bodies jump from the ground. You see, here I said F minimum equal question. So this I want to find.
الفكرة إنه بده يحاول يوجد أقل قوة ممكنة. إحنا حسب المسافات هسه حسب المسافة اللي بيحتاجها حتى إنه الجسم ينطلق الآن. فبده مشان يوجد أقل قوة ممكنة عندنا الآن.
The minimal force M2G over K is the minimal tension in the spring. Yes. No. In that moment, it's sure that the body jump. Only that. You see, what I have to verify now, I have potential gravitational energy. I have elastic potential energy. But maybe I push too hard the body. And if I push too hard, what's happened? The both body jumps up. So I could have kinetic energy. I don't know how is it, but I write in red because after that I explain why. I could have M1 V1 square over 2 plus M2 V1 square over 2. That means the same speed because, or maybe different speed, doesn't matter. Yes, but I ask not what is the force. I ask what is the minimum force. That means I am interested only that the body is splitting, not at what height he arrive.
هو اذا بتلاحظوا انه هو بيحاول بده يوجد اقل قوه ممكنه اللي بنضغطها. اذا بتلاحظوا في الجزء الاول من المعادله عندنا طاقه الوضع اللي بدانا فيها بتساوي ام جي في L0 ناقص ام جي على كي، هذه مسافه الانضغاط. لاحظوا الترم الثاني ناقص اف على كي، اف القوه اللي انا اثرنا عليها على ثابت الزنبرك. فلو كانت اف هذه قيمتها كبيره راح تكون عندنا على الطرف الثاني في كميه طاقه حركيه، لكن اللي مسحها الان اللي كانت بالاحمر هذه، فانا بدي اشوف الوضع اقل قيمه للقوه اف بحيث القيمه اللي مسحها هذيك الاحمر تساوي صفر، يعني ما بدي يكون عندي طاقه حركه، لانه في اللحظه هذيك الجسم بده يبدا يتحرك عن سطح الطاوله، والطاقه الحركيه في هذه الحاله تساوي صفر.
So this is the equation for this problem. When you solve it, I don't solve it because it's only mathematics. I have nothing else to do than to open the bracket and simplify and reduce. Yes? You obtain the final result, which is F minimum equal M1 plus M2G. This is the final result. If you open the brackets, you make all the calculus, all the reduction, yes, you obtain this result.
فراح تلاحظوا اذا حليته في عندنا مجهول واحد اللي هو الاف عندنا في هذه الحاله. مظبوط؟ في المعادله هذه. فبقول اذا حليتوا المعادله هذه وفكيتوا الاقواس وما الى ذلك، بعد شويه حسابات الجبريه في النهايه راح يكون عندنا اقل قوه ممكن راح تساوي M1 زائد M2 في جي.
As you see, K, L0, which we have introduced, there are no longer.
إذا بتلاحظوا إنه ما في أثر لا ثابت الزنبرك، يعني لو كان عندي زنبرك صغير له كي قليلة كبيرة إلى آخره ما له. لو كان اختلف طول الزنبرك أيضا، لأنه اختلف طول الزنبرك هيختلف إيش؟ كي، وهكذا ما لها أثر. فقط
They are reducing
M2 على
or simplifying.
Okay.
You understand? So if I want to do a calculus, I can do it in this final relation. Yes? So I don't do the calculus, only introduce the M1 is 70 10 minus 3 kilo plus M2, which is 30 10 minus 3 kilo. Yes? And G is 9.81, so kilogram meter over square meter. That means Newton. Okay? So, you see the calculus only in the final relation. Very simple, very easy. Yes? Is 10 power